What if I told you that some of the world's smartest scientists once announced the discovery of a new particle that turned out to be completely imaginary? It had a name, a mass, and even made it into textbooks. It was supposed to explain one of physics' greatest mysteries. But there was just one problem. It didn't exist. This is the story of how a simple mistake fooled the scientific world, costing millions of dollars, confusing decades of research, and teaching us one of the most valuable lessons in science: that even the best minds can be wrong. To understand this story, we have to go back to the mid-20th century, when physics was exploding with discovery. Einstein's relativity had reshaped how we saw the universe. Quantum mechanics revealed the strange behavior of matter at the smallest scales. And deep inside this world of atoms and energy, scientists believed there were still secrets left to uncover. Hidden particles that could explain the forces holding everything together. Every time a new particle was found, the proton, the neutron, the electron, it felt like unlocking a new chapter of the universe's manual. So when strange results started appearing in particle detectors in the 1960s, the physics community thought it might be witnessing the birth of something truly revolutionary. At labs in the US and Europe, scientists were smashing protons together at nearly the speed of light, hoping to see what matter was made of. But then, they noticed something odd. The results hinted at a new, unseen particle, one that carried a strange kind of charge, one that could exist inside atomic nuclei but had never been detected directly. The data looked convincing. The signals matched a theoretical prediction. Physicists rushed to give it a name: the Upsilon meson, a particle they thought explained anomalies in nuclear forces. Papers were published, conferences buzzed with excitement, and in 1963, newspapers around the world declared, "A new particle has been discovered." Except, it hadn't. The so-called new particle was an illusion, a ghost created by statistical noise. You see, in particle physics, discoveries depend on probability. When billions of collisions happen every second, random fluctuations can appear to form patterns, even when there's nothing there. At the time, computers weren't as powerful as today. Data had to be analyzed by hand, and the tiniest bias could create a false signal. The teams had simply overinterpreted their results. By the late 1960s, more advanced detectors showed no sign of the particle. The discovery quietly disappeared, never officially retracted, but gradually forgotten. The Upsilon meson became one of physics' great embarrassments. But here's where it gets even weirder. In 1977, over a decade after the false discovery, scientists at Fermilab in the United States found a real particle, and its name, the Upsilon meson. This time it wasn't a mistake. The new particle was genuine, a bound state of a bottom quark and its antimatter twin. Ironically, the name of the fake discovery from the 1960s was reused, this time correctly. So now, there were two upsilons, one imaginary, one real. A cosmic mix-up that turned an old blunder into a new breakthrough. It might seem embarrassing that top scientists could make such an error. But this story isn't really about failure. It's about how science corrects itself. Every discovery begins with curiosity and uncertainty. Mistakes happen because scientists are pushing the edge of what's knowable. When new data contradicted the original discovery, the community didn't hide it. They re-examined, recalculated, and refined their models. In the end, that's what makes science powerful. It's not perfect. It's self-correcting. For every wrong turn, we get closer to understanding reality. The fake Upsilon meson may have never existed, but chasing it helped refine the tools, methods, and theories that led to real discoveries later on. Today, with machines like the Large Hadron Collider, we can simulate billions of collisions and check every signal to a precision that 1960s physicists could only dream of. But even now, mistakes happen. In 2011, scientists thought neutrinos were traveling faster than light, something Einstein said was impossible. After months of investigation, they discovered it was just a loose cable. So yes, even modern physics still has its oops moments. But that's okay. because each one reminds us that discovery isn't just about answers, it's about questions and the courage to admit when we're wrong. The story of the particle that didn't exist isn't a story of failure. It's a story of growth, of how humanity learns, corrects, and moves forward. And that's the real beauty of science. Not that it's always right, but that it always keeps trying to be. So, the next time you hear about a revolutionary discovery that might change everything, remember the story of the particle that didn't exist. Because sometimes, the road to truth is paved with the things we thought we knew. If you found this story as fascinating as I did, be sure to hit that like button and subscribe for more deep dives into the biggest moments in science. Thanks for watching.